My name is Venilisi Kunanan, and we're gonna talk about logarithmic functions. Logarithmic functions. So, first we need to know what is a logarithm. Logarithm, it is the power to which a number must be raised in order to get some other number. So, example, the base 10 logarithm of 100 is 2 because 10 raised to the power of 2 is 100. So, this is an example of a base 10 logarithm. We call it a base 10 logarithm because 10 is the number that is raised to a power. Next example. The base 2 logarithm of 8 is 3 because 2 raised to the power of 3 equals 8. So, we use base 2 logarithm in this example. In general, you write log followed by the base number as a subscript. The most common logarithms are base 10 logarithms. They have special notations. A base 10 log is written. So, log. And a base 10 logarithm equation is usually written in the form. So, log A equals R. A natural logarithm is written. So, we write ln. And a natural logarithmic equation is usually written in the form. So, ln A equals R. So, when you see log by itself, it means base 10 log. When you see ln, it means natural logarithm. In this course, only base 10 logarithms will be used. So, base 10 logarithms. We saw above that base 10 logarithms are expressions in which the number being raised to a power is 10. So, the example here, the base 10 log of 1000 is 3. We use the base 10 logarithm. So, what is logarithmic functions? Logarithmic functions are the inverses of exponential functions, and any exponential function can be expressed in logarithmic form. Similarly, all logarithmic functions can be rewritten in exponential form. Logarithms are really useful in permitting us to work with very large numbers while manipulating numbers of a much more manageable size. So we see here, if x equals 2y were to be solved for y, so that it could be written in function form. A new word or symbol would need to be introduced. If x equals 2y, then y equals the power on base 2 to equal x. So the word logarithm, abbreviated log, is introduced to satisfy this need. Y equals the power on base 2 to equal x. So this equation is rewritten as y equals log base 2x. So this is read as y equals the log of x base 2 or y equals the log base 2 of x. So a logarithmic function is a function of the form. So we have example 1 here. Rewrite each exponential equation in its equivalent logarithmic form. So the solutions follow. So number 1, 5 with the exponent of 2 equals 25. So it will only become 2 equals log base 5, 25. So we put the 2, the exponent here, the 5 exponent 2 will become 2. So we put only log base 5 in the number 5. So we copy only the 25. So that's the answer in number 1. Number 2, 4 with the exponent of negative 3 equals 1 over 64. So it will only become negative 3 equals log base 4, 1 over 64. So again, the exponent will only write again the number, negative 3. So the 4 will only put log base form. So equals log base 4 over 1 over 64. So the base remains the base. Example number 2. Rewrite each logarithmic equation in its equivalent exponential form. So the solutions follow. Example number 1. The log base 36 equals 2. So it will only become 6 with the exponent of 2 equals 36. We multiply it 2 times, so 6 times 6 equals 36. Next one. Log base a m equals p. So the log base a m equals p, it will only become a with the exponent of p equals m. So again, the answer here, we put only exponent the p because m equals p, so we only change positions. So the base will only remains the base. Last example. Solve the following equations. So number 1, log base 749 equals y. So we change positions again. So since 49 equals 7 exponent of 2, so we change position only. So the log base 7 and the y, it will become 7 exponent of 2. So it becomes 7 exponent of y equals 49. So 7y equals, so what is the multiple of 49? So 7 with the exponent of 2. 7 times 7 equals 49. So the answer here is y equals 2 because we remove the numbers here, the 7. So the remain will be y equals 2. So that's the answer of number 1. Number 2, log base y 8 equals 3. So since 8 equals 2 with the exponent of 3, so again, we change position again, the log base form and the 3. So it will become y with the exponent of 3 equals 8. So again, y 3 equals, so what's the multiple of 8? So 2 times 2 times 2. So we multiply it 3 times, so it will become 8. So we gonna do here is we remove only the same. So y equals 2. So we remove again the exponent because they are the same. So that's the answer in number 2. Number 3, log base 3 negative 9 equals 9. So it will only become 3 with the exponent of y equals negative 9. So we change positions again, the log base 3 and y. So we remove the log base form. So we put 3 with the exponent of y. So the negative 9 will remain the same. So that is only how to solve some logarithmic equation to exponential form or exponential form to logarithmic form. So this is the last discussion. Thank you for watching.